Hello everybody and welcome to Let's Code for the Older Folks. My name's Leslie Thatcher. Hope you're all well. Glad to have you with us. Now, in this session we're going to be moving on. If you remember the last session, we looked at the DHT11, humidity and temperature sensor. Well, today we're going to look at a new sensor. It's called the BME680. It not only measures temperature and humidity, also monitors pressure and gas, air quality. So it's a very good module for weather stations. All right, weather stations. Now, obviously, you're going to be using a Micropython software and that ESP32. It's a quick, simple little circuit and sketch. It's just to familiarise you with when we get later on and we do build our weather station, how this is all put together. All right. So, as I say, it reads volatile organic compounds, VOC, VOC. All right, so volatile organic compound. Let's just go over here and let's go to here and let's show you the sensor and build the circuit. So what we got here is the sensor. Hopefully you can see that. Good. All right, 6 pins. We've got 3.3 volt data. And we've got the SCL, that stands for clock. And then next to that, we've got the SDA. All right, stands for data. And then we've got another 2 pins. Won't explain what they are at the moment. We won't be using them in this project. Right, so let me just now on our drawing. Let's go to our drawing. Oh, sorry, quick picks. On our ESP32, we've got dedicated I2C pins. And if you look up here to the right hand side, they are GPIO 21. All right, which is the data. And then we've got GPIO 22, which is the clock, the 2 blue ones. Right, so that's the pins we're going to be using. Right, 21 and 22. Right, let's go back to here and let's build the circuit. So our first one. Okay. Just into the board. Okay. Our first one, VCC, goes to 3.3 volts. Remember, rows connected, columns are not connected. No, it's the other way. Columns are not connected, rows are connected. Right? So first, then we got ground. Rightio. Then we got ground. And then next we've got is our clock. All right, and that goes to ESP22. Sorry, GPIO 22. And then we've got our data, which then goes to GPIO 21. Right, so that's our circuit built. Simple little circuit. Now, your sensor will not come with the kit that I've got linked below. So what I've done, I put a couple of links where you can get this sensor because it is a bit of a speciality sensor. You will have to purchase it. Okay, and that's going to happen in the future when we start getting into a speciality sensors, modules, etc. you will need to purchase them. But if you go to the right place, they're cheap enough. All right, they're cheap enough. So let's have a look what we've got to do now. The next thing we've got to do, let's go over to here. We're at our Sony IDE, Integrated Development Environment. Now, a lot of these specialty sensors need libraries. And these libraries are normally produced by the sensor manufacturers or individuals. Now, so the first thing we will need to do is install our BME680.py sensor. Now, down below, I have got a link. I have got a link. Go to this link. All right. And what you need to do, it is a big library. Right. It's a big library. Highlight it all. Highlight it all. All right. Up to here, right click. And we copy it. Back to our Sony. File. Open. Okay, and we're going to, close that. File. New. All right. Right click. Paste. Rightio. And paste it into our Sony IDE. And what you want to do is, we want to make this, you know, quite presentable. Just take out the comments. Now, comments are things that are highlighted with hashtags. All right? Such as this. All right, hashtag I2C. We don't need that. Just take it. But do not take anything that is needed. So anything with a hashtag, you can tidy up. You can leave it if you want, if you're not that confident. All right? But I would just tidy up what you can, right? Then we need to go File, Save As. Save it to the Micropython device, right? So we open our Micropython device. As you can see, I've already got mine saved. So call it BME680.py. All right, and then click OK. Then click OK. I've already saved mine, so I'm going to click Cancel. And then you'll have something like this. So I've tidied it up a bit. Got rid of all the quotes. Next thing you need to do is open a new new session, IDE, be called Untitled. All right, and we need to then start our sketch. Make sure I'm at the right place. Bear with me, bear with me. Oh, we saved. Right. We're now going to write our sketch. And first thing is from machine. Import space pin, capital P on the N, on the pin, comma, space, capital I to capital C. So from machine, import pin I2C. So what that's telling the ESP32 is that we're going to be using the dedicated GPIO 21 and 22 as I2C pins. I'll just say, not a mistake if you see it before. All right, I2C. Right, so that's what that's telling the ESP32. And then from time, import sleep as normal. Enter. And now from our library, from BME 680, import, wildcard. Okay, whatever we need to import from BME 680. Okie doke. So far, so good. Now we need to do our pin assignments as normal. And ESP32 pin assignments are as follow. Small I, 2C, right? Space equals, okay? And it's capital I2C. Brackets on. SCL for clock equals pin, capital P on the pin, brackets on, and we put that on 22. Parentheses off, comma, space SDA equals pin, brackets on, and we put that on 21. Right, hang on, and all right. And then finally our brackets off. Close the brackets. Yeah. Right. Then BME, all small case, equals capital BME 680 underscore capitals I 2C brackets on, parentheses on, I2C equals I2C, small case, parentheses off, brackets off. So far, so good. Come down. Now we need to do the guts of the program. So we've done all our classes. All right, and done all our pin numbering, etc. So while true, capital T on the true, colons, enter, gives us auto indent. Try, colons, indent. Space equals str for string, brackets on, round, brackets on, BME dot temperature, comma, space 2, brackets off, parentheses off, parentheses off, space, plus. Then we want a quotes, space C, quotes off, enter. Clicking that, okay. Space. Then humidity for hume equals str, string again, parentheses, round, brackets on, okay, and yep, brackets on, BME dot humidity, comma, space 2, brackets off, parentheses off, space, plus, space, I want to get this right, space percent, quotes off, enter. Next, pressure, PRES equals STR, brackets on, round, brackets on, BME dot pressure, space 2, parentheses, parentheses off, space, plus, and we put a space, quotes, H, capital P, small a, quotes off. Right? And then gas, voc, okay, equals string str, brackets on, parentheses on, round. Right, round, yep, brackets on, BME, gas, / 1000, comma, space 2, brackets, brackets, space plus, space quotes, KO, capitals, HOMS, quotes off. Right, okay. So, bring this all down, space, then we need to print this all out, don't we? So, print, brackets on, quotes, temperature, colons, quotes, and then, so not quotes, then it's bracket, and then it's TEMP, parentheses, enter, print. Parentheses, quotes, humidity, colons, quote, comma, HUM, parentheses off, print, and parentheses, quotes, colons, quotes, space, sorry, comma, space, pressure, PRES, parentheses, enter. Then it's print, on, gas, colons, comma, basic gas, brackets off. Last print, on, quotes, and it's 1, 5, 6, 7. There's 7 dashes here. Quote, quote, and brackets off, parentheses off. All right. No mistake until you until you run the program. Print. Okay. Space. Then backspace and come under the try. Right? The try. Remember I told you how important these indents are. Right? Except. All right. So if don't do any of this, do this. All right. In case there's an error. So OS capitals. Error. Capital E. OS error as E. Quotes. Right, space gives it auto indent. Come down a bit so you can see. Okay. And print on quote. Failed to read center. Full stop. quotes, full stop, quotes, brackets off. Right, backspace. Right, backspace. So we're under the accept and try. Right, sleep. Brackets on, 5. Brackets off. So every 5 seconds, remember, sorry, we do milliseconds, so every 5 milliseconds it will sleep. Right. Now then, let's just quickly go through, make sure I don't see any obvious mistakes. Oh, file, save as, Micropython device. I'm going to overwrite my main. Okay. And okay that. And we want to overwrite yes. Right. So far, so good. Let's run the script. Line 7. BME. Let's have a look here. 7. BME equals BME680 underscore I2C. I see. Yep. I did capitals instead of small case. Right. Right there. So that was my mistake there. Let's file. Stop it first. Okay, let's file. Save it. And let's run it again. 15. 15 pressure. PRES equals SCR brackets round BME dot pressure phase 2 brackets plus HPA. Let's stop this again. STDIN. I'm going to hold it there and just do a quick debug and I'll be back with you. Hi there, yep. Couple of mistakes I've noticed. I've left out a comma there. Check you got all your commas. And I forgot a quotes there. So let me stop that. And let me file save that. Let's try running it again. Hopefully no more mistakes. Line 22. Line 22. Of that again. Right, the quote before the where the quote should go. There. Okay. So I include all these typos, you know, because we're all going to make them. We're all going to make the mistakes. Let's file. Let's save that again. And let's try running it. Has seen that already. Okay. As. Right then, let's stop it. Hopefully that's the end. Let's save it. And let's run it. And there we go. So a few small typos there, a few small typos. But as you can see, that's every 5 seconds, temperature 20, humidity 60, and VOCs 7.54 KO ohms, pressure 1020.91 PHA. Well, guys, took a little while to get there. It's working. It's working. Hopefully, you will purchase this sensor because we're going to be incorporating it later on in some of our sessions, some of our projects. Hope you enjoyed this. If you did, please give us a thumbs up. Please don't forget, whatever side it is, to subscribe. All right? And I'll see you in our next session. Bye-bye. Bye.